Today I'm just going to give a little introduction to the course, a bit of housekeeping, what you can expect, and then we'll dive straight into the first proper chapter, which is chapter 2 in the notes. Okay, we're not going to complete that today, but we'll just, and that's just going to be there's going to be some revision in there. Okay, some of the material might be new to you, but because of the way I'm going to go about teaching it, but it shouldn't be that far-fetched. Okay, so let's just dive in with the intro. Welcome everybody. The structure of the course, it's a 20 credit course, which means normally you should have 2 hours every week in this session in this room. Okay. The way I'm going to run the sessions is a bit like a lectorial. There's going to be some content presentation on the screen, and I'm going to go through some worked examples as well. Now, previous years when I've run this course, there's been quite a, not so many as you guys. Last year it was about 50 in the room, and so I could actually run a proper tutorial where you're all working in groups or on your own, and you could come and you could work on your own problems. But because this room isn't really set up for tutorials, I'm not going to do that. Okay. So in terms of working on your own or in your own time, you're going to have to do that outside of this class. Okay. But like I said, I am going to supplement the content with worked examples. So we're going to have you're going to benefit from all that time instead. It runs in both semesters. Okay. Teaching block 1 and teaching block 2. So they've got 24 weeks of me. The assessment takes the form of one exam at the end of the year. Okay, there's no exam in January. There's no coursework whatsoever. It's one exam at the end of the year. It's 3 hours long. The format of the exam is you've got to answer 3 questions from 4. Okay, so essentially you've got 1 hour per question. Gives you an idea of the sort of level of question we might be asking you. There's no coursework. And new for this year is I'm planning on running some in-class quizzes. Okay, I'll tend to give you a small break in the middle of the session because it's 2 hours long. And at that point we might run the in-class quiz. There's no credit associated with those quizzes, so it's up to you how you choose to use them. You can use them as formative feedback, and essentially what I'll do is I'll hand out a little question. I'll either put it up on the screen or give you a piece of paper. You can work through it, and then after the break we'll go through the solution to it. But they're very, very simple questions. Like I said, 5 minutes is tops. If you've got questions or comments, you can email me. That's probably the preferred method. You can call me. And if you want to find me, I'm in 1N23, okay, which is the small office at the back of 1N22, that big open plan office, which is by the entrance to N block. Okay. And if you want to see me, you can call me from the phone in the foyer, and I'll come out and meet you if I'm in. Now these course notes. This is part 1. There are 2 parts. Part 2 is not finished yet, which is why you haven't got it. But you'll see that in the margins of these course notes, there are little numbers marked up. Okay, and these numbers give an indication of the slide number, where we are. Okay, we're on slide 5 out of 7 for this introductory lecture. And if you look, slide 5, which is on page 9 in the margin, you'll see that that's the same sentence as what's written in the notes. Okay, so essentially the notes and the slides go hand in hand, they go together. Okay, and if you get lost, just look at the slide number and you'll know where we are in the notes. Okay, essentially that's what's going on. So these notes will cover the first, I think, seven chapters, okay, of this work. Chapter 1 isn't really a chapter, it's just this introductory stuff. But chapter 2 will start today, which is all about single degree of freedom systems and the basics to do with those sort of systems. You will have noticed that there's a camera in the corner of the room, okay? And that's because every lecture, every session that we're going to be doing in here, I'm recording, okay? And they're going to be posted on YouTube and will be embedded into Blackboard for you to look at. And if you want to go to my channel, fancy re-watching some level 1 fluids or level 1 dynamics or even control systems, then if you go to my channel on YouTube, you can watch a bunch of videos from that. This is the first time this lecture, this module is being recorded. It's partly because there are some part-time students in level 2, and they're not here because their part-time day isn't a Tuesday, it's a Thursday. And so for them, I'm running a tutorial just for that cohort on the Thursday, but they need to watch the lecture beforehand because they've only got an hour, and I don't want to repeat myself. But obviously, that benefits you as well. So if you've seen me in the lecture theatre and there was something that wasn't clear or you want to go over it again, then go and find the video on YouTube on Blackboard. It's not an excuse to not come to the lectures, because there may be things that I decide not to record in the lectures. Okay, so it's up to you whether you turn up or not. And if I cover something that's not being recorded, or I cut out of the video, then obviously you will miss it. Okay? And like I said, I may decide to cut it out as opposed to just not record it. So you don't know what I'm cutting out and what I'm not. But in reality, I've done some research about lecture recordings and lecture captures and stuff, and it turns out that there is something you get from actually being in the room rather than passively watching it on the internet. Okay, so there is something, you still get benefits of turning up. But it's there to support you. Conventions, obviously, we'll use SI units. If I'm talking about units like newtons or meters or kilograms, that's generally written in the upright font. Okay. Whereas variables are normally in italics, so x and theta here, okay? Just some conventions. Vectors are either with curly braces or with an arrow over the top. More likely than not, it'll be with curly braces. And then matrices are with square brackets. And I also use dot notation extensively, okay? So if you're not familiar with it, get familiar with it. Basically, a dot over a variable means it's the first derivative with respect to time, okay? Always with respect to time. If it's with respect to something else, it won't have a dot on top of it. And 2 dots, obviously, is the second derivative with respect to time. So if x is the displacement, then dot x is going to be a velocity, and double dot x is going to be acceleration. Okay? It just means that I don't have to keep writing d by dx or d2 by dx squared. Okay? It's a lot quicker. If I'm talking about something and you forgot what it was or you don't know what it is, then stick up your hand and ask. I'm not worried if you've got a question at all during any of these lectures, stick your hand up and I shall aim to respond to them. I'm not precious about this whole formal, I'm the lecturer, I know everything and you're just going to sit there and watch, okay? If we can get some interaction going, that's great, but I understand that doing so with 100 people is not the most comfortable of situations for everybody. And at the end of chapter 1, there's some indicative reading list. You don't need to go to the library to get these books out, okay? Because everything that is going to be covered is going to be in these notes, okay? But if you wanted some more information, then by all means go to the library and get those books out. They're just a few suggestions. I suppose as a guideline, there's going to be a lot of maths in this module, okay? So you need to make sure you're up to speed with Engineering Maths 1 and 2, okay? I shouldn't cover anything that's beyond your maths, okay? There might be a few things, but it's more in terms of its application than anything else. But there is going to be a lot of maths, okay? So you need to make sure you're up to speed in algebra, differentiation, integration, that sort of stuff, okay?